We'll now look at the chain rule for derivatives, and this is when we start dealing with compositions of functions. So we have something like f of g of x, and we want to find the derivative. These are going to be a little more complicated. Essentially, the formula says that we have f prime of g of x times g prime of x, which can be a little difficult to read and figure out exactly what to do. The shortcut easy way to think of this is it's the derivative of the outside times the derivative of the inside. And we'll do some examples to figure out exactly what that means and how this works. First, I'm going to find the derivative of e to the 8x. And while we do know how this works, we're going to now explain exactly why it works this way using the chain rule. So I can say that g of x is e to the x, and we know the derivative of that is just e to the x. And this is essentially what we're doing. We're taking the derivative of e to the x, which is just e to the x, and then we have to take the derivative of the inside. The derivative of, in this case, the exponent. The derivative of 8x is 8. And so this is where this comes from. We know that the derivative of e to the x is e to the x. So we keep the same function, and then we have the derivative of the inside, which in this case is the exponent. This works the same for things that we've dealt with like sine and cosine as well. We know that the derivative of sine is cosine, and then we have to take the derivative of the inside, the derivative of 3x, which is 3. And this is where we get the 3 cosine 3x. Let's do an example that maybe we haven't seen before. Here I have the derivative of, or I have the function x to the 4th minus 3x squared plus 2 to the 5th power, and I want to find the derivative. The chain rule says we're going to do this exactly like we would do a normal polynomial. We bring the exponent down and subtract 1. And that's our derivative of the outside part. Now we have to multiply by the derivative of the inside, the derivative of that polynomial inside the parentheses. We bring the 4 down and subtract 1 to get 4x cubed. Bring the 2 down and subtract 1 to get minus 6x. And the derivative of 2 is just 2. 4th power there. So now we have our derivative. We took the derivative of the outside, just the fact that we did raise something to a power, times the derivative of what was inside the parentheses. What about something like e to the cosine x? Well, using the chain rule, we know that the derivative of e to the x is e to the x, so the derivative would be e cosine x, times the derivative of the inside, which in this case is the exponent. The derivative of cosine is negative sine, so we have our answer, e to the cosine x times negative sine x. Next, we want to take the derivative of cosine of 4x to the 5th plus 7x squared. We know the derivative of cosine is negative sine, so we have negative sine of 4x to the 5th plus 7x squared, times the derivative of the inside, which in this case is this polynomial. We bring the exponent down and subtract 1 to get 20x to the 4th, and then bring the exponent down and subtract 1 to get 14x. So now I have the derivative of this function. Let's do one more. Here I have the function the square root of 4x squared plus 7 minus e to the sine x, and I want to find the derivative. First, anytime we're finding derivatives with square roots, it's probably going to be easier to rewrite it as an exponent. And remember, a square root is the same as a 1/2 power. So now I can use my power rule that says bring the exponent down and subtract 1. So I have 1/2 times 4x squared plus 7 minus e to the sine x to the negative 1/2. And then we need to multiply by the derivative of the inside. The derivative of 4x squared would be 8x. The derivative of 7 is 0, and now I have to take the derivative of e to the sine x. We're going to have to use the chain rule again. The derivative of e is e, and the derivative of sine is cosine. Running out of room. I'm going to go ahead and rewrite this as 8x minus e to the sine x times cosine x all over 2 times the square root of 4x squared plus 7 minus e to the sine x. Remember, a 1/2 power means square root, and negative means we are going to move to the bottom of the fraction. So in this case, we actually had to use the chain rule once. Once for the fact that we had this exponent outside the parentheses, and then once again for that e to the sine x.